All right, I think we're live now. I'm going to just record a screencastify video for you guys to show you how to do this worksheet. It's the one on the screen. I don't know if this will work best. I'm going to attempt to use a stylus and Cami to show you what to do. I think it will be better than using a webcam and just pen, old school style. We'll see. Tell me in the comments what you think. So here's the first problem. And basically, this is similar to what you were kind of exploring yesterday in the lab. So we have three vectors, A, B, and C. They're all different lengths, which means they're different magnitudes, and they're in different directions. So we're just trying to figure out if we could add all these up together, if all three of these happened at the same time, what would the result of that be? How would it look? So I'm going to zoom in again, attempting not to make any... All right, there we go. So the first thing we want to do, the lab was calling it I and J, which is just like a math thing they were doing, but we can call it east and west or north and south or X and Y. It doesn't matter, but east, that's to the right on your paper. We're always going to call that positive. And west, we're always going to call negative. So let's look at the first one. What you want to do is break them up. How far east is it going? How far west? How far north? How far south? So we start here at the bottom, and the arrowhead is the end, showing the direction it's going, and we can count the boxes. It looks like we're going 1, 2 to the east. East is positive, so positive 2. Again, my handwriting's already bad, but now I'm trying to use a stylus. It is what it is. So now B, we need to figure out its east component. We start here and we go over 1, 2 boxes, so it's also a +2. Then we look at C, and we go 1, 2, 3, 4, 5, 6, 7 boxes. So this has an east component of +7. Pretty easy. They were all going to the right. They're all going the same direction. They're all going east. So that was an easy one. If, let's say, B was going to the left, same size, same magnitude, is just going to the left. Instead, it would be -2. So now to figure out the resultant of our east, west, left, right, we just add these. So 2 plus 2 is 4. 4 plus 7, you get a total of +11. That's a terrible positive sign. You get the idea, probably. So now let's do the north-south component. So looking at A, we start here, and how many boxes up do we go? 1, 2, 3. So this has a component of +3 because, like before, east was positive, now north is positive, and south is negative. B starts there, but it doesn't go up or down, so it doesn't have a north or south component. It's +0. And C starts here, and how high up does it reach? It only goes 1 box up. So this is a +1. So the total, the resultant would be 1, 2, 3 plus 0 plus 1. So we have a +4. So all these together, it doesn't matter which order you do them. You could go vector A, then vector C, then vector B. Doesn't matter. They're going to add up to a total of moving to the right 11 spots and moving up 4 spots. So now I'm going to just shift the page, and I want to draw what this would look like as one single vector. So let's see. We'll do the east component first. So that was green. So let's just say we start here. I have to go 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I need to go 4 north. So 1, 2, 3, 4. You may be wondering why I line them up this way. And this is, again, the tip to tail method. So we're just doing one path, then the other. And that's how you get from where you start to where you finish. If you wanted, you could have done the pink one first. So let's say we still start here, but we will go up 4. 1, 2, 3, 4. And then the green one we could do next. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, it doesn't matter if we go right first and then up, or we go up and then to the right, because we're going to end up in the same spot. And this is how we get our resultant vector. So the resultant vector is all your vectors. It could be an infinite amount of vectors added together to just get the result. And you start here with your resultant, and you go to where you finish, which is over here. And I will do my best to draw a straight line. And then, of course, put your arrowhead, and we'll label that R. That's our resultant vector. So again, just drawing it, that's all of our vectors added together, A, B, and C. They are equal to R. But now we need to figure out the length of R, and that's where a little math is going to come in. So there we have it. I'm just going to zoom in to make it easier. So we're going to use our classic A squared. Why is this such a thick font? I don't want that. So we're going to use A squared plus B squared equals C squared. So here it doesn't matter which one's A or B. We have 11 squared plus 4 squared equals C squared. So 11 squared, just double checking my calculator, 121 plus 16 equals C squared. Oops, glitch. C squared. So what is this? 137 will equal C squared. Take the square root. And what is that? Oops. Using the calculator. Nope. Come on. You probably got it by now. C is equal to 11.7. And that checks out. It's the hypotenuse. It should be longer than the longest side. Longest side was 11. So the resultant, after all that, a vector addition was 11.7. So if you're thinking about distance versus displacement, here your displacement would just be R, 11.7. Meanwhile, the distance you walked if you went green to pink would be 15. And the last thing is to find the angle. So the direction. So the angle we're going to find is right here. That's the angle we want. So you could use SOHCAHTOA, any of them. Uh-oh. It's getting a little glitchy on the Chromebook here. So we will use, let me get rid of that little blob. Okay. We will use tan because that's what your lab is using. So tan of theta equals the opposite over the adjacent. So tan of theta, equals the opposite, which was 4, divided by the adjacent, which was 11. So the way you want to plug this into your calculator, oops, that's not what you want. You got to move the tan over, so what you end up with is theta equals the inverse tan, so -1 of 4 over 11. So on your calculator to get theta, make sure you're in degree mode. And that tan with the -1, it's printed on your calculator. It's second tan. It's that button above the tan. And then 4 divided by 11. And you should get 20 degrees. 19.98. We'll round it to 20 degrees. So there you go. And again, you could use sine or any of the other ones because we know all 4 sides of our triangle. So label it. This was 11.7. Jeez. This one's 11. This is 4. This is 11. This is 4. So you have 2 separate right triangles here, but they're the same thing. One right triangle, and that's what we're looking at there in the blue. All right, so that's all I got. Let me know what you think. Or maybe I can't stop the video.